Yeah, it's the unknown mechanic here, and you get to look over my shoulder while I try to fix a Stihl chainsaw. I forgot everything I was going to do. Must be this Joe. Okay, now I remember. All right. Let's look at the tag. Okay, it says it was running, then died, won't restart, low compression. And it belongs to Clem Yodelhopper. Okay, let's have a closer look here. Let's make sure the compression release isn't on. Okay, that's off. That's pretty low. I'm going to take the barn chain off to make it easier to work on. Looks like we've got a tight joint in the chain here. Check that out. That doesn't look good. Put this aside. Oh yeah, looks like he's been using this chainsaw as a rototiller. I'm going to bring the camera in for a close-up here. So. Okay, that's pretty roasted. Usually a professional saw will have a floating rim sprocket, and when the chain comes off, it's not going to do damage to the drive links like this. This is a spur style sprocket, and if you throw the chain, you're gonna have this kind of problem. So we'll address that later. Chain catcher looks like it's a little bit questionable too. All right, a little deeper. I see the problem. We don't need to do a compression test. There's no threads, no spark plug threads left in the cylinder. They're stripped. So I'm going to show you how to repair that. I know there's a lot of videos out there on chainsaw strip spark plug repair. Some good, some not so good. I guess you'll be the judge of this one. We're going to start by taking the muffler off. And there's two reasons for that. First reason is we want to make sure that the piston and cylinder are not scored. Because if we're going to repair a cylinder on something that's overheated, and it's just a waste of time. Should replace it. The other thing we're going to do is show you the different tools and methods that I like to use, and because if you do this wrong, it could cost you a cylinder. And on a saw like this cylinder goes all the way down, and it's in a plastic crankcase, and it's not like a removable cylinder. You have to take the engine out of the saw. It's a lot of work. So you want to be able to do this in place and minimize the amount of labor. So let's take the muffler off and check the condition. Okay, that looks really good. I'm going to bring the so up here, you can get a look at it. Hope you can get a good look at that. That looks brand new. I can still see all the machining marks on the piston skirt. So it's got very low hours on it, perfectly repairable. I had one mechanic who, supposedly had 40 years experience, and he came to us when he was semi-retired, and we used him in the off season. That's when he was available, and 1 day a week. And what he would do is, as soon as he saw the slightest little scratch in the piston skirt of any machine, he would condemn it. And he had a very low percentage of machines that he actually repaired. He would tell the customer that it was beyond repair. Then when he would leave, my other mechanic would fix all of those machines and give them back to the customer, and he'd never know. So we called him Scratch. Sadly, Scratch is no longer with us, so don't need to worry about that now. I'm going to show you the next step is on my cutaway. What we want to do is position the piston in a specific spot to minimize any chips getting into the lower part of the engine. So we want to position the piston so that the exhaust port is just opening. The piston's on the way down and the port is beginning to open. That ensures that only the highest port is open. The next ports, the transfer ports and the intake port, are below that. And if the piston is in that position, then there's no chance of any chips getting into the lower part of the engine and damaging the main bearings and the crank throw bearing. So let's see, I'm going to do that now. Okay, piston's coming down. Let's see, a couple of rings. Okay, now it's opening. Going to leave it there. We're also going to use gravity so that the chips are going to want to fall to the lowest point. So I'm going to tilt the saw so the exhaust port is pointing down. There's my little bar buddy for that. show you some of the tools that I prefer to use. This is a helicoil, part number 5523-14, 14 millimeter repair kit. Judging by the sticker that's on it, it looks like it came from that large aftermarket lawnmower parts company based in Georgia many years ago. They no longer sell helicoil. They switched to a different brand. And I'm going to talk about some of the other brands that are out there later after I repair this. But let's take a look inside here. And first, we've got a piloted two-step tap. This leading pilot is just standard 14 millimeter, and then it graduates to an STI 14 millimeter oversized tap with sharpened reamer flutes here. And I've run into some very small displacement chainsaws that this tool, when it starts to go all the way through, it runs into the cylinder wall, and so I had to add a second, same part number, but modified. I've ground off most of the pilot, and this will allow me to, I have a couple examples here. This is a Poland Super 25 cylinder. Used to be very popular back in the day. And as you can see, the tap is going to run through there, and it's going to run into the cylinder wall or the combustion chamber. So here's another example. This is a Stihl cylinder. I used to do a lot of these. Same thing, very small displacement, and the tools, when it goes through, it's going to run into the cylinder wall or the combustion chamber and not allow you to completely oversize the stripped out spark plug hole. So that's where this modified tool comes in. Don't see too many 0.3Ts anymore. 25s. Yeah, so once you begin with the unmodified tap, just before you run into an obstacle, you can remove it and then complete the hole with the modified tap. And next we have the insert installation tool. And this is what allows the insert to be wound up so that it's small enough it will enter the hole. In a helicoil's free state, it's much larger than the hole, and you can't get it to start without this tool. Then we have 14 millimeter carbon tap. I've used this, occasionally you run into an overhead valve engine that's got a long reach plug, and somebody, accidentally put in a flathead plug, 3/8 reach, very short, and, the engine would run poorly, and it would carbon up the bottom 2/3 of the hole. And then when you go to put the correct spark plug in there, it would go in 1/3 of the way, and then it would hit the carbon. And so you can chase that full depth hole with one of these taps. I've actually upgraded that tap. Here's the upgrade. This is a high-speed Stihl tap with coating, and this style of tap is capable of threading hundreds of holes in very hard material, whereas the carbon tap is really only meant for chasing existing threads, not cutting new threads, especially in something hard like steel. And next we have the mystery tool. And you're probably wondering what that is. I'm going to show this in use in a few minutes, and this is one of the secrets, the tricks of the trade. It's very important. I'm going to pause for one moment. Okay, the unknown mechanic back again. I had to pause for a moment, go get my other cutaway. I'm also going to show you, let's see, a couple other tools. This is a time cert kit, and I'm going to talk about that after I repair this. There's one little advantage to using this, which I will explain. And then I also I haven't used it yet, but a lot of the new lower emission engines use a 10 millimeter plug. You know, a lot of the Stihl low emission saws, not all of them, like this one, this is a low emission saw, and it's still got the 14 millimeter plug in it. But I bought this 10 because I know I'm going to need it, and it happened to go on sale, so I picked it up at a good price. I'm going to probably use that in the future. And let's see. The important thing that you want to identify is there are two types of stripped spark plug holes. One is just an over-tighten, where the plug is over-tightened and it pulls the threads right out straight. And the second type is a little trickier to address, and that's a cross thread. And that can happen if you should always start a spark plug. This one's loose. When you start a spark plug, you want to start it by hand. And that way, if it's going to go in crooked, you're going to get about a turn out of it, and then it's going to stop, and you're going to know that you can straighten it out. You want to get it in there, and that way you'll never have a cross-threaded plug, and you do your final tightening after it's seated with your wrench. Okay, so let's talk about this one here. I'm going to bring the camera in real close. Let's see if we can. Yeah, hard to get a good focus. Maybe. Just I don't know how good you can see that. We'll take a look at the plug too. Probably hard to see on the camera. Plug looks brand new, and the one of the clues is that the compression washer does not look compressed. So I don't think that this plug ever threaded all the way down and seated. And this gasket surface here, that's something I don't like to mess with. You want to try to preserve this machined flat surface for the gasket to seal properly. So hard to see, but it looks to me like this is a cross thread. And the cross-threaded ones are, you want to pay a little more attention when you're repairing those. And the reason is that if you just take your piloted tap and you've got a cross-threaded situation, plug's leaning over, and you strip the threads from a cross thread, it's going to be harder for this tool to enter the hole straight, it's going to want to lean at an angle. And then if unfortunately, these STI style taps in all of the thread repair kits that I've seen, including this time cert kit, the pilot that leads, it shares the flutes with the graduated large oversized tap. And that means that this pilot, it will cut. If you start crooked, it's going to cut crooked. It's going to cut crooked all the way through. And for that reason, whenever I would turn over one of these strip spark plug repair jobs to one of my inexperienced mechanics, we had Scratch, who supposedly had 40 years experience, and then we had Dingus, and we had Gomer. And they couldn't start one of these things straight if their life depended on it. And after I fix this, we're gonna talk about the rant that you probably don't want to listen to. So that's where the mystery tool comes in. And this is nothing more than a piece of 7/8 diameter handlebar tubing off of a lawnmower. And it was cut to the proper length. And it's just the right length. And the ends, you can't just take a hacksaw and whack off a piece of lawnmower handle. It's got to be square. So this tool was turned in a lathe. Both ends were turned in a lathe, and it's 100% square. And that's going to sit on here on the gasket surface, and it's going to sit exactly perpendicular to the gasket surface that compresses the compression washer on your spark plug. And so you can drop your tool down here, and don't let this move. Drop your tool down here, and then you can start straight. And that's what I'm going to be doing with the chainsaw. Now, talking about a flathead engine, once again, the engine block is in the way. This tool is going to run through here, and it's probably going to run into the block. But on a flathead, you can easily remove the head, and you can block it up and do this on the drill press, and you'll get 100% square perpendicular to the plug, and it'll come out perfect. It's interesting. There was an urban legend that was circulating around, in the early 80s, maybe the late 70s, at the Briggs & Stratton Update seminars, where a customer had partially stripped a flathead plug hole in an engine similar to this on a reel type lawnmower, I think. And he somehow got the plug in there, half-assed, and he was, tinkering with the engine, trying to start it and get it to go. And it blew the plug out, and supposedly it hit him and killed him. I don't know if it hit him in the head or what the story was. That just may be an urban legend. But, you want to repair the threads properly so that they're going to attain the full torque value. On a chainsaw, the cover of this type is certainly stout enough it can contain any kind of projectile explosion of the spark plug coming out of there. So, anyway, enough with the cutaway. Put that down there, out of the way. And we're going to get this ready. So the helicoil and it's free state. It's larger than the parent material after you've tapped it out. So we're going to be using the winding tool, and we're going to shrink that down and put that in there. And one of the other trade secrets that we're going to use to contain the chips, but this is a little bit different than other videos that you've seen. I'm going to pack grease only on the pilot. Okay, I am not going to put the grease on the second stage of the tap. And we'll get to that in just a second. This is going to help collect the chips, and some of the chips are going to be extracted and held in this grease. So the other secret trick of the trade is you use a good cutting fluid. And this is Winfield Brooks, Winbro for short, Alum Tap. They make a brother chemical to it called Tap Free. And this recipe is still available. I checked on it. The Tap Free has been replaced by some green aqueous water-based stuff, and I don't know how good that is. But the Alum Tap and the original recipe is currently available, and this is one of the secrets. You do not use grease as your cutting fluid. You use the real thing. This stuff I've used for many years, and it produces outstanding results. The hole tolerance is very accurate to the cutting tool. The surface finish is perfect. And I hope I can get a close-up of that. And so we're going to stand this tool up here to help guide this one straight, because I think this is a cross thread. And even if you're not sure whether it was an over-tightened pull-out or whether it was a cross thread and it's crooked, there's no harm in using this tool to help guide you to start. So another secret besides the cutting fluid is the driving tool. You want something that's got two handles on it, and this is a little large. This would be if you were cutting new threads into very hard material. This is oversized and kind of unnecessary for how soft this is. So I prefer to use an 8-point socket on a T-bar. But what you don't want to do is have it one-handed. Do not use like a ratchet or anything. You want two hands, and that's going to, when you're turning this, you're going to be turning both, and it's going to equalize the torque, and there's not going to be any lean over. That's very important. So I'm going to drop this down in the hole and get it started. Okay, yep, now it's definitely started. Okay. I know that I'm started straight. And now I am going to use the cutting fluid. And it does not take a lot. So another thing that Scratch and Dingus and Gomer would do is they would back up the tap to break the chips off. That's totally unnecessary. You do not want to do that. That is only when you're tapping very hard material and the chips need to be broken off for you to continue. You go through once. You do not back up. You can pause and add more fluid. And any chips that are dropping in there are now going to come out the exhaust port. I'm equalizing the torque. Push with the thumb and the fingers. You go all the way through. No backing up. And it is through. Okay, so once in and once out. Okay, so the grease captured quite a bit of the chips. And the chips, there's still some chips in there. I'm going to pause the camera and I'm going to take this outside. And I'm going to blow down first and with low pressure air because I don't want to blow the piston down and open up the other ports. And then I'm going to blow low pressure air out the other way, and that should do it. Pause for a moment. Okay, back, and now we're going to show you as good as I can the result prior to I don't know how well you can see that, but the tap was not leaning over back and forth, you know, when some inexperienced mechanic is trying to start crooked and then straighten up and then go in, you get an oversized hole. This hole is perfect, and it looks like it's about 6, maybe 7 threads deep, and that's going to determine which insert we're going to put in it. Okay, we're going to use a 7/16. It's about, in its free state, it's about 5 threads tall. After it's wound up, it'll probably be about 6. So we're going to put this on here so that the tang is captured in the hook. And then we're going to put it in the funnel and wind it, and it's going to shrink. Okay, and we're going to come out pretty much flush, right about there. And we're going to put it over the hole, and we're going to wind it in the hole. Okay, I'm gonna take this off prematurely just so you can see before it's completely in there. Okay, it's not all the way in, and so you can just see it like maybe 80%, 90% of the way in. And I'm going to continue, and it's got to be below flush, and that's very important, especially after this. I'm going to talk about some other brands of thread repair kit and let you know what I've seen in the past. Below flush. I do no longer need this. I'm going to finish with this. And I'm going to go 1/4 to 1/2 turn below flush. And I like that. And now we're going to talk about how do you get the tang off. Okay, the all helicoil inserts, except there's some that are tangless, they are pre-notched so that you can grab this with a knockout tool or pliers and it will break right there. And unlike the aluminum chips from the tapping process, if 1 or 2 of those are left in the cylinder, they're not going to do any damage. However, if this tang is broken off and goes inside the engine and is not retrieved with a magnet or some other method to extract it, it will destroy the engine. And if I were to turn this tool set over to Dingus, Scratch, or Gomer, and they did not come to me with this broken off tang and show that they had retrieved it out of the engine, I would make them tear the engine all the way down until they found it. I don't care if it's on the floor and they find it on the floor later. You cannot leave this tang inside the motor. Very important. So the easy way to get it out of there is this hole is so large, 14 millimeter. I'm going to grab this with needle nose pliers and I'm going to pull it out. Don't have my pliers with me. I'm going to pause. Hang on. Okay, back with pliers. Needle nose pliers, a good pair. And there is the removed tang. Okay, sorry about that. Had to pause. I completely forgot to get a new spark plug. Must be some lingering after effects from that cup of joe. Anyway, let's have a look at what this is. And this is the correct spark plug. It's an NGK BPM R7A. And I'm I'm going to bring this in for a close-up. Okay, and if you look carefully, you can see some thread damage. And also the washer looks totally uncompressed. And there's evidence of a lot of gas blow by the threads here. And that plug is brand new. But I don't trust it, so I'm going to replace it. All right. So also I'm going to bring you in for a close-up of the finished job before I put that new plug in. Hopefully we can get a good view here. Okay, hope you can see that. And we're ready to put a new plug in. Okay. Now, many years ago, we used to use the Bosch WSR6F, but in most Stihl owner's manuals, it shows that they prefer the use of a solid terminal spark plug, not a removable terminal. So we just haven't been able to find Bosch spark plugs at a good price with a solid terminal and that are not made in China. So we've been using these forever as a result. Now before I put it in, I'm gonna check the gap. And the spec for this is 0.5 millimeter or 20 thousandths of an inch. And the smallest wire that I have is 22. It's a little big. And that goes in really easy. So let's see just how big it is. Put 25 in there. It's about 25, 26. So that's too big. So I'm gonna shorten that down. So this one is a 20 thousandths or 0.51 millimeter. That's what I'm going to set it for. It's a little tight. Okay, that's good. I like that. And you're probably wondering if this hole has been enlarged and the insert is now recessed below flush, is there going to be enough gasket surface to seal this? Well, if you measure the STI portion of the tap, it measures about 618, and the OD of the gasket is about 750. So that's 132 thousandths or 66 thousandths on each side. And when this tightens down, this is going to flatten out and it's going to grow, and it's even going to gain some sealing So let's go ahead and spin this in. You always want to turn these in by hand until the gasket touches, and then you know that you don't have a cross thread situation. You'll never strip one. So next is the torque setting. Now I printed a sheet out of the service manual, and these are all the torque specs, and the spark plug is the largest one in the entire chainsaw, and they want it tightened down to 25 Newton meters. Now, interestingly enough, the next smaller one down is the clutch carrier. It's 12 millimeters, but it's a lefty, and they want it tightened down to double 50 Newton meters. That's double the spark plug. And the reason for that is the crankshaft is a Stihl forging, and it's a lot more stout, and that's going to require higher torque. Now, the torque wrenches, it's important to know that when you're doing the clutch carriers, a lot of torque wrenches are 2 to 3% accurate in the forward direction only. They're less accurate in the reverse direction. So you got to be careful about which torque wrench you select for the clutch carrier tightening. You want to make sure that you got a torque wrench that's accurate in reverse. Now, I do have some newer digital electronic snap-on torque wrenches that with the touch of a button you can switch from inch to foot-pounds and Newton meters to inch pounds and back and forth and other settings. But I do kind of like old school tools, and so I'm going to be using this Snap-on QC2 FR75. It's a 5 to 75 foot-pound, and right now it is set at it's set at 5 pounds, which is the minimum setting. That's where you want to store it, so it will always stay in calibration and storage. It won't go out of calibration. So I'm going to dial this up. So that's 10, 15, 16, 17, 18 and a half, right there. And a lot of helicoil skeptics think that they are not as strong as the original threads. If properly installed, this helicoil insert is stronger than the original threads that were in the parent material. And I'm going to demonstrate that by torquing this down to the full value. And there it is. And I can do this all day long, hundreds of times, and that's not going to strip. That would represent, changing the spark plug 100 times during the lifespan of the saw. That is a permanent repair, and that's not going to fail. So I'm not going to waste your time showing the muffler and the top cover and the bar and chain going back on it. I'm going to pause, and when I come back, we're going to give you some more technical information about other types of thread repair insert kits and what I've seen. Okay, I didn't want to waste your time while I put together the saw back together. It's all back together, and now I don't need to test the compression on this. This thing is like new. Big difference. I'm going to talk about some four-stroke. I already talked a little bit about a four-stroke, but this is an example of a overhead valve head that is stripped about three-quarters of the way. It's stripped. There's only a few threads left at the bottom, and what you can do on a head like this, these heads are removable a lot easier than a chainsaw head, and you can start from the good side, start from this side and go inside out. That guarantees that there are no chips left inside the engine, and it also guarantees that you're going to go straight. And you notice on this Honda head, this is not perpendicular to the cylinder. It's at an angle, and so it's a lot harder to tell when you're working with one of these funny angled ones. If you wanted to do it from the outside, that's again where you would use the mystery tool, and it's going to square up right against that compression gasket seat that's machined into the engine and guarantee that you're going to go exactly the way you're supposed to. So if you want to see this one done, you can leave some comments if you want to see me do this one. This is a scrap head. I think Scratch, Dingus, or Gomer, they were too lazy to try to attempt a helicoil, so they just swapped heads off of a junk engine, and this came off of a customer's unit, and they just put another head on it with good threads and went back to work. So I think we're done with this. I'm going to address the chain issue with the customer on that, get him a new chain, but other than that, it's good to go. I'm going to pause now that I'm done with this, and when I come back, we are going to address some of the poor repair kits and poor methods that are out there that I've seen fail, and I'm going to share that with you and caution you on what not to do. Okay?